All right, so I'm recording now. So first thing you do is you go to PASS-Start for you to get a free trial or demo version of the software, and it's going to last for 30 days. So that means effective today, you are supposed to be using it for your simulation and all your analysis. After 30 days, you have to renew again for you to be able to use it. So once you're on PASS-Start, you come to the upper right corner, you're going to see free trial. Then you click on free trial. So my network is kind of slow, but it's going to open up. So under the demo, you'll be able to install from here. So you're going to see this interface, all right? Then you just come and click on the button, try it. So it will ask for your name, you put in your name. Who are you? So we are going to write a student, all right? Job title, put in AIGE trainee. To be easy for us to track you that way. Organization, AIGE Limited. Country is Nigeria. Business phone number, you add your phone number. So you see, include the country code with plus. So you go with plus 23480. Then you continue and you put your name is 70, you continue. Then email, put your professional email. Industry, you should put oil and gas. How did you know about software? Then from software reseller, which is what we are at AIGE Limited. We are the official reseller of PASS for the West African region. Then you have this color code that you're supposed to fill in. In my case, it's 65252. Then you submit. Once you do that, your download should start automatically. All right? So go ahead with that and get the software onto your laptop. So once you've downloaded and installed Start Prof on your system, it's going to come with this logo. So you can see this logo that I highlight, Start Prof. So you're going to have that logo, and that is the universal logo of Start Prof. So if I ask, what does this look like, this logo, what does it represent? Anybody can tell me? Like a bisected circle. Okay, that is a good start. Anybody else? So this is a cross section of a pipe. It's not a circle. All right, the circle, what you are calling a circle is a cross section of a pipe. Then you can see what you have as this red, all right, is the pressure in the pipeline. So this is how you represent pressure. So pressure is least from the middle of the pipe and is highest at the boundary. All right? So you should take notes for that going forward. So that should be your first lesson from this lecture. Okay? So that is how you represent pressure on the pipeline. So you right click and you open. So my program is opening. Download activation, I just did that. Just a minute, let me quickly fix this. So now I have my interface open. I can maximize so that I have the full screen. Yeah. So the first thing you want to do is you want to understand the interface of Start Prof. All right? And the first one we have here is the file. And the file will tell you either to open a brand new project or to open an existing project where you have open, or even to import. All right, so this import is very important because Start Prof is not the only CAD software available, but you can import from other CAD softwares. All right, that's why you can see the Plant 4D, PCF file, Plant Space, Plant 4D, PDLS. All right, all these are other CAD softwares that you can import from. Maybe if you have a model that you've built in such software, you can import it and use it to run your pipe stress analysis on Start Prof. Then also we have the print setup. If you want to print, this is your key. Then view, toolbar. So this tells us the arrangement of our ribbons that will be displayed. We have the standard toolbar checked and the status toolbar also checked. Then this has to do with the styles. Styles has just do with the appearance of the background of where you're working from. So all these are different appearances. So take for instance, if I click on gold, just watch, you can see the appearance has changed. All right, has changed to gold. I wish this gold can turn to money, maybe some naira notes, but you know, so that's just for the color. All right, so you can work with different background styles here as you wish. Okay, then also we have Windows 10, Windows 8, Windows 7. All right, so if I click on Windows 10, I have something like this. Okay, so that means this is compatible for my Windows 10. All right, you have other Windows too, depending on the Windows you are using, Windows 8 and Windows 7. So this will help for compatibility issues as we are working on Start Prof. Then we have services. Okay, so you can also restore default environment. So let me do that. So it's restoring my default environment. Do you want to reset? I say yes. Then it will result back to my default environment. All right. And there we have it. So you have services. I can customize my background. This is where you can do it. Then I also have database. So Start Prof has database for a lot of materials. Okay? All the materials that you can use to build your pipelines. The database is imputed into Start Prof. That is where you have the material library. All right. So if you click, you see the different codes. All right. Because we are in Nigeria, we'll be using process piping. And you have a material called A105. So all these are different materials. And these are international codes that have been used to customize different materials. So let's go to Google and see the material that is called A105. And let's see what we're going to have. All right, so I'll say Google, what material is A105? So you can see seamless forged carbon steel. All right. So that is for A105. So all these other, let me go back to my interface. All these other codes that you see here are different materials. Okay, these are the international codes. And all this is, if you want to know their definition, is represented in engineering codes and standard ASME B31.3. I have a version for myself, but not for distribution or redistribution. So you will see all these materials and their description. So a customer might tell you that I want to design my pipeline with tungsten carbide, for instance, or I want to design my pipeline with stainless steel. So this is where you can find all the different material and ensure that you use the exact material. Because if you don't use the exact material, the stress analysis that you are running, you can get it wrong. So I'll close that. Then apart from material, you have spring support. And for spring, we have variable and constant spring support. Vincent has said a lot during the presentation about the different spring supports. So all these are the different spring supports available. They are contained here. You have the database. Same thing with the soil type. So who will tell me one of the soil type that we have?
Loamy soil.
Okay.
Soil.
Okay. So you are all correct. So all these have their representation along where you want to install your pipelines. So right from the stage of the design, you have to get right the soil that will be encountered where you are going to install your pipelines. Then we also have insulation. What is the purpose of insulation? Can you tell me? Not you. The man online. Can you tell me the purpose of insulation? Why,
Purpose of insulation.
yes.
I don't have an idea.
Okay. So let's see. Let me hear you. What's the purpose of insulation?
Insulation is simply protecting material from conducting electricity.
Okay.
Insulation also heat loss.
Very good. That is the primary purpose of insulation. It prevents heat loss. Okay. You know that when we are constructing our pipelines, we are not just constructing pipelines for construction's sake. We are constructing it to move or to transport a particular fluid. You understand?
Yes.
Either liquid, either gas, either aqueous.
Yes.
All right? Yes. So you want to ensure that anything you are moving is not impeded. All right? Because there's a temperature that a gas will get to and it will cake. There's a temperature that hydrocarbon will get to and it will cake. All right? And to start forming things like what we call the hydrate, things like what we call the wax, things like what we call the emulsion, all right, which can hinder the flow of a pipe. And imagine a situation whereby you constrain the flow of a pipe. What do you have at that point of constriction?
There could, there could
Hello?
be building pressure at that
Very
point.
good. So you have
I said there
build
could
up.
be build up of, okay.
Perfect. You can have build up of pressure. Okay? A typical example would be if you are in your house, maybe you have a water hose. When you close a particular point on the water hose, you will discover that over time it will be hard for you to close it again because more is trying to pass, and as more is trying to pass, there will be a pressure buildup. So at that point in time, two things will happen. Either the pressure buildup will be so strong to force its way through, or if the constriction is too strong, then you have what we call a pipe burst. And that is what you don't want, okay? Because it's like you saying one of the veins in your body is being cut off or cut into two. What do you have at that point? You can have bleeding, all right? And when you bleed to a point, what happens? You go and meet your creator, all right? So I'm trying to give real life scenarios to what you guys have known to now take you to what you are supposed to know, all right? So these are the simple basics that you are supposed to know as we go along in this course, okay? So back to my point, you want to have an insulation on your pipeline to ensure that if I'm going from here to 10 kilometers, the temperature of the fluid at the starting point should be warm enough at my 10 kilometers so as not to have a change of state. All right? Either from solid to liquid or from liquid to gas. That is another broad topic called flow assurance. We have that topic too for those of you that are interested. All right? And you want to ensure that you don't have such situation, because if you have such situation, you can have a disaster, just like I have explained earlier on. And that is why insulation is important. And a typical insulation is your water flask. So when you see your water flask, you see that you have a lot of heat convention materials round about it. When you were in school, you did heat transfer, didn't you? Somebody say yes, not sure. Okoyemi, did you do heat transfer in school? Hello?
Yes, I did the transfer.
All right. When we are talking about
Yes, I did it.
conduction, convection, and what? So now you're back. So now you're back. All right. So the essence of them teaching you all this is also to explain insulation. Okay, because you want to keep your content warm enough till the market point or till the collection. All right.
So I want to keep the fluid temperature constant.
You can't keep it constant. There will still be temperature drop, but at least at the collection point, you still want the product to be warm enough so as not to have a change of state. Okay. Because take for instance, even your food flask or your water flask, if you have hot water in it and you hold the flask, what do you feel? You feel it's warm, isn't it? That means you have some heat losses. So you can never do without heat loss, but that is what you do in your analysis in flow assurance. You want to, and that is what will lead us to a term which is called the cooldown temperature. You want to be sure that whatever you're transferring from a point A to a point B, the cooldown temperature does not go below the temperature to cause a change of state that would drastically affect the flow of your fluid or whatever you are passing through the pipeline. Is that understood? Yeah. Then next we have the expansion joint. The the design we are going to do today, we are going to design an expansion joint. All right. So what will be the importance of expansion joint?
The purpose of expansion joint is to allow the fluid pass through this.
Okay. 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 What? Who else? Okoyemi, do you have anything to say? No response. Okay. So when we talk about expansion joints, metals generally don't keep a state. All right. Once there is high temperature, they expand. Once there is cold temperature, they contrast. All right. So the function of the expansion joint is to keep your pipeline within the design limits during the work time or during the work duration of that pipeline. And a typical place or an example where you use an expansion joint is when you go over bridges. Okay? At the starting point of a bridge, midpoint of a bridge, end point of a bridge, you have something like girders. So that when your car goes over it, you hear gup, 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 gup. Have you ever wondered why you have that? That is to allow for expansion. So those are gaps that on a very good or a very hot day, the metals of the bridge can expand into that gap. And on another day, it can contrast backward. All right? So that is the essence of an expansion joint. Okay? So let's move ahead. The next one is pipelines. We've talked about pipelines. Then we have what we call bends. Okay? So bends are also the part of a pipeline that helps us to take a change in direction. Okay? So we can have a change in direction, maybe 90 degrees, maybe 45 degrees. All right? Bend help us to do that. Then we have a T. What's the difference between a T and a bend?
A T and a bend.
Yes.
A T at a point goes in different direction, but a bend goes in one direction.
Okay, that is a point. What else? Koyemi, do you have anything to say?
No, but I didn't hear what he said.
The difference between a bend and a T in pipeline.
Difference between a bend and a
T. A T.
okay.
Look at T
No.
on your screen. This is T.
Yes, I've seen it.
So what's the difference?
I think a bend there's just one direction, but T is there are two diversions.
Okay. Somebody has said that. So both of you are right. Also, a T can allow for joining a pipe at 90 degrees. All right? But anything other than 90 degrees is a bend. Bend can take any other angle of inclination. Okay? It can also take 90, it can take 45, it can take 30, right? But a T is at right angle to the other pipe. All right? Then we have a reducer. What's the function of a reducer? What's the function of a reducer?
The reducer is to reduce the width or the diameter of the pipe.
Diameter reducer. That's it. So maybe if we have a 10-inch pipe and we have another 15-inch pipe and we want to connect them together.
We reduce the 15-inch pipe.
No, you just have to use a reducer. It's standard. So you just have to get a reducer that is 10 at one end and 15 at the other end. So it will come like a funnel. All right. So one end, the 15-inch end will be welded to the 15-inch pipe. The 10-inch end will be welded to the 10-inch pipe. So that is the function of a reducer. So also we have gaskets.
Gasket.
So what is a gasket? What's the function of a gasket? Hello? Okay, I mean, what's the function of a gasket in pipeline construction?
Gasket.
What's the function of a gasket? So let's take a break. While you answer that question, yes, let's continue. So what's the function of a gasket? I'm still waiting for response.
To hold two
Like for me, I don't know what a gasket looks like.
two pipes together.
To hold two pipes together. Aha. So there was not the function
Yeah,
of a
like
flange.
prevent.
Aha. And you
Okay, I
are
think
also mechanic.
gaskets probably to.
Go ahead. I'm listening to your question.
Yeah, I think to prevent maybe leakage
Now you
between
are talking.
two pipe joints.
Now you are talking. So, let's see. You were trying to say something.
No, I said I don't really know what a gasket looks like. So I may not be able to see the function.
So you don't know it. Now it's not an issue. You don't know it. You don't know it. What's the gasket?
A gasket is a sealing material. It's self-seal two flanges. Kind of sealing material that seals two flanges attached with a handle.
Okay. So Okoyemi and Ugochukwu are on track. Leslie said he does not even know a gasket. So thank God he came to this class today. Because after now you know a gasket. So mostly in engineering components, you know that our pipeline is metallic, isn't it? It is made up to a flange that is still metallic.
Yes.
So when you join metal to metal together, two things happen. You cannot permanently prevent leakage between two metals at the interface of the two metals. Do you understand? You still have some form of little leakage because metal and metal, they are both rigid. So we now have a material that is more flexible to be in between the two metal to metal contacts. So that no matter the fluid going inside the pipeline, you don't have leakage at the point of intersection of those two metals. So that is what we call a gasket. It is also applicable to your car. If you see a place where they open a car engine, you will see something that has hole, very flat like this. Like a paper, it has hole, all the whole of the cylinders. Then all the other places where you have holes. You have it on maybe the bottom, what do you call that again? The bottom what? Are you there? The bottom
Yeah, but
cylinder.
I didn't hear your last statement.
You have the bottom cylinder, you have the gasket, then they now place the top cylinder on it. So at that point you can now seal the engine.
Yes.
All right? So that is a gasket. Then the flanges are the after one that you can see. You see a pipe, you see another pipe, the end termination of those pipelines, where screws go into and nuts, those are the flanges. So I'm making all this explanation so that next time when you see a pipe or you are just passing, you just don't look at it as a pipe. You try to look out for all these intrinsic parts, all right, and make sense out of it. Does that make any sense to you guys?
Yes.
All right.
Yes, sir.
So let's continue. Then we have different stress codes. So somebody can ask you that what stress codes do you have in Start Prof? These are all the stress codes that we have. All right? In Start Prof. You have the ASME codes, you have the Germany codes, the Russian codes, the Chinese code, the ISO codes, which is
Not the American code.
yes, that's the ASME is American, but ISO is European. All right?
ISO.
So these are all the codes you have in Start Prof. Then here also you can customize your units. So take for instance, you can work in meters, millimeters, centimeter, foot, inch, and decimeter. Can you see that? Then this is for the length. You have it in meter. Then you have your diameter in millimeter. You can also change it to have your area. But just ensure that anything you're doing, your measurements are accurate. All right? So for length, I put it in millimeter so that it will rhyme with what I have here. Okay? Are we together?
Yes.
Then I click also for your moment. You can see you have everything. Then,
moment in centimeter.
yes. Okay. So, Newton meter. All right? Then you have temperature. You have angle in degrees or radians. You have density. You have mass. You have central moment of inertia. Then you can click OK. All right. So now you are used to the interface. Let's go to do a small work. So as if you want to start a small work, you go to File, right, and do New. But you can see this New and Open are also here. Can you see them? So you can as well just click it at this point. So you click New. So you have pipeline, which is pipe analysis, stress analysis of piping, elements. Then I just click OK. It's loading.